Okay, and welcome back. So we're going to talk about the trapezoidal method now. Here's the old function again, but this time I've drawn it properly and made sure it tails off at the end. So it is a quadratic with a turning point at 3,10. But it still works the same because we're just working with numbers and this is a guidance diagram. So I've got the coordinates here. What if I wanted to use a trapezium? So I'm going to draw my little dotted lines again here. And I'm going to break this up into 4 trapeziums. We were using rectangles, and you'll remember that our upper rectangle method yielded 34, our lower rectangle method yielded 26, and our mid-rectangle method, or the average of the other two, yielded 30. So let's have a look at how this compares. So, what I'm going to do is build some trapeziums. But first I want to remind you about how to find the area of a trapezium. So the area of a trapezium, based on, and this is the classic way you'll have learnt it. Here's your trapezium, here's B, here's A, hopefully that's on the screen, if not, that's an A. And we have a vertical height. So here's our trapezium, and the area of that trapezium can be calculated as area equals a half A plus B times by the height. Okay, so think about it this way, if you don't recall. When we do our half A plus B, we're actually just getting an average of A and B. What that does is it creates a rectangle where the B length is shortened to match the A length. It's kind of giving up some to A, which will create this rectangle here. So I just draw that little dotted line down there and there, and that triangle there and that triangle there has been moved to there, and this has been moved to there to create a rectangle. So now half A plus B is the length of the rectangle and H is the height of the rectangle, and we get the area by multiplying. So there's our area of the trapezium. I want to create some trapeziums here. So I'm going to draw these dotted lines, which hopefully you can see when we did our little lines earlier for the rectangles, they were clear over and underestimates. But in this case, it's pretty close to the curve. And if you do this on Desmos or do it a bit more accurately than me, you'll see it still is pretty close to the curve. When we get these turning points, it moves away a little bit, but it's not too bad. So the trapezoidal rule is about building up an estimate based on trapeziums. And I'm going to use this formula. So what I'm going to do in this case, just in this instance, and there is a formula that we'll get to later, is I'm going to determine the area of this underneath here by calculating the area of each of these individual trapeziums. This shape here is a trapezium. It's just turned on its side and it's got a flat base. So I'll draw it over here. It looks like this. I'll only draw the first one, but I just really want you to see this. It's been rotated around and it's got a height of 1 because this is 1, and this short side is 1 while the tall side is 6. So my scale is clearly wrong. There's 1 and 6. Okay, and I'm not worried about anything else. Basically the area, and I'll call this area 1, is equal to a half times 1 plus 6 times 1. And 1 plus 6, half of that, that's 3.5. Now it's important to note here that this is going to be an underestimate. I've got a little bit of space here, 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 and here. There's a very particular reason for this, but it will be an underestimate. So let's continue building our understanding. Area 2 will be equal to a half. 6 plus 9, 6 and 9 are there, times by 1 again. That times by 1 is going to get a bit boring. 7.5. Area 3, you do the math for me. 9 plus 10, a half of that is 9.5. And then area 4, 9 and 10, half of that is 9.5 times by 1. And therefore the total area under the curve is 9.5 plus 9.5 plus 3.5 plus 7.5. I'll write it down. That way if you're taking notes, it's there. And that's equal to 19 plus 11, that's equal to 30. Which interestingly is that. It won't always match this. We've got a pretty simple function. I know it's a quadratic, but it's a fairly simple function. And that is going to be a fairly good approximation of the area under the curve. What I'm going to do in the last video, so I'll rub this off, is I'm going to formalise with a general curve. I'm going to formalise the trapezoidal rule, and then I'm going to let you add it, because the trapezoidal rule like this isn't too bad. Easy function, easy ordinates to determine, substitute in 4 different times, add them together, easy. if I wanted to improve the accuracy, what I would do is I would split it up into 8 trapeziums. Okay, which is all good and well. And then I've just got to do this 8 times. Well, then if I want to improve it again, I'll split it up into 16 trapeziums. Now this is getting out of hand. So there is a rule, and we're going to develop that rule in the last video. Thanks.